All right, check your understanding with checkpoint 18.2. We have a hypothetical reaction here, and we're told it's a second order reaction. Okay, these are coefficients which we don't use to determine rate laws. Very important to remember that. Um, there's a special case where we can do that, but we haven't gotten to that yet. All right, so if the initial concentration of A, so there's our reactant. Pick a different color here so it stands out. Concentration of A. Um, so let's just, um, and then it's giving us the rate. We can build our own table here. All right, no, pick a different color, match this up. And then it didn't give us a second it's given us the rate. All right, so it's a little twist to this kind of problem. All right, we haven't seen one of these here, so we can still use kind of the ratio method we've been using. So we can do like this. Let me I guess it doesn't matter which side. I've been doing the rate on the left. You know what, let me do this actually. So here's the rate law. The rate is equal to the rate constant K, little k, times the concentration of A. That's the only reactant we have in this thing. And that's raised to the X. We don't know what, oh, we are told it's a second order reaction. Okay. All right, it was told that earlier. All right, so we're just going to keep using this format because that's the way we've been doing our problems. All right, so the rate here I'm going to use right there in blue is going to be 9.6 times 10 to the negative 7. Moles per liter is molar. Per second is, I'm going to just move that to the numerator there. Okay, and that's going to equal, doesn't really line up as really well, but the concentration of A is given to us as 2.0 moles per liter is molar. Okay. Now, we're just going to put that over the ratio of the second trial. Let me get some more room. Okay, so second trial, all right, we have the rate is 1.2 times 10 to the negative 7. Now you see why we move these exponents all to the numerators, because then you get complex looking fractions. And anyway, we're looking for what is the concentration at that second rate. All right, and we are told this is a second order reaction, so we can do like this, and we can do like, we can do like that. Okay, or we can just write this whole thing like that. Okay, the property of exponents. Okay, so you know what? We better use our calculator for this one. All right, so punch in your calculators. Let me get my down there. You know what? I should have flipped this around. You know what? It's not going to matter. Just an extra step. That's fine. All right. So ratios are ratios. I could have put the numbers in red on the top. I'm thinking that might be a tad bit faster, but it doesn't. It's not going to really matter. All right, so I'm just punching the numbers in my calculator. 9.6 divided by 1.2. It's going to look. Oh, it's a pretty number. That's okay. So I do all of that. Punch that in my calculator. I'm going to get 8. All right, and these bases they're going to cancel out. So it's just 8. I'll do 8.0 because we have 2 sig figs. Right? Those cancel out. Those cancel out. Right? They're all gone. It's just 8 is left over. That's gone. All right. So over to the right side, I'm just going to simplify this a little bit. So 2 squared is 4. And that's molar, 2 molars as well. And then on the bottom it's going to be x squared. All right. I should have just wrote it the way I originally had it on the right side. All right. Now we're solving for x. So this is what I mean. If I had the red numbers on the top, I could just simply divide by 4 molar squared. But I'm going to rearrange this. Give me a little more room. Okay, so I cross multiply. 8.0 x squared is equal to 4 molar squared. Okay, so divide both sides by 8. More room. Okay, let's cancel out. X squared is going to equal 2. That's just 1/2. Right? And take the square root of that to get x. Okay, square root. So x is going to equal 2. All right, in your calculator, 0.5. Oh man, where's my square root button? Square root of 0.5 equals 2 sig figs. Just go 0.71. And look at that. That's our. Oh, wait a minute. Hold on. Square root of that is. Okay. And that, look at that. That is concentration, unit of concentration. Right, so there is the final answer, is the concentration. Or you could write that as, because molar is moles per liter, you can also write that as 0.71 moles per liter. They both work.